Okay, let me ask you this question here. We've got two cars having a race. Car one here would be traveling at a constant speed of 10 meters per second. So this car is going at the same speed all the time. There's zero acceleration. Versus a car that starts from rest. So the speed at time equals zero is zero. But then it starts at rest, but then it will constantly accelerate at 3 meters per second squared. So here, your car one here, the speed time graph for car one would be like this. It's always going at 10. The speed time graph for car two would be like this. So it starts at rest. So car one here, what it means is that car one started down here somewhere, but then it slowly builds up speed. So by the time it gets to the starting line, it's already doing 10 meters per second. That's why when time equals zero here, it's already doing 10. Whereas the second car, it starts at zero. Remember, this is a speed time graph. Okay, speed time graph. It doesn't represent the distance. Well, anyway, over a course of 100 meters, which car will win? Car one or car two? So think about it. So press pause and place your bet. Okay. All right. So to do this, it's hard. It's hard to do it inside your head. So let's draw a speed. Well, let's look at graphs. Okay. Hang on. Let's see how we can do this. All right. So for car one here, car one here, and then we've got car two here, car two. Remember, car two is the one with the acceleration. This one, it starts from rest, but with the acceleration. Whereas this car one here, it's already doing it. It's already doing 10 meters per second, but with zero acceleration. Okay. So hang on. Let's start again. So car one here, car one. Car two. Okay, let's start with the acceleration time graph for car one. Well, the acceleration for car one, which is the one up here, there's no acceleration. It's going at the same speed all the time. So the acceleration will be zero. Okay, and remember, we are talking about car one now. So car one, the acceleration will be zero. The speed time graph. The speed time graph will be like this. Okay, because it's going at the same speed all the time. It's going at 10 meters per second all the time. So the speed time graph would just be a horizontal line like this. Okay, and so the distance time graph will look something like this. Okay, the car one is covering the same. Well, the distance time graph will look like this. Car two. Remember, car two is this one here. Okay. Well, the speed is zero when time equals zero. But the acceleration is 3. It's going to accelerate by 3 each time. So there is an acceleration. So when your acceleration time, when you look at the acceleration time graph, there is an acceleration of 3. It's always accelerating at 3 meters per second squared. That means the speed time graph will look like this. Because if you're given the speed time graph, there will be a gradient of this line, and this gradient is 3. Okay. So here so when you have when a speed time graph is a diagonal line like this, then the distance time graph will be a quadratic. So distance time graph will be a quadratic. So here the formula for this line here will be, well, y equals 3. It's always 3. Here y equals 3x. Okay. Well, in this case, t is x and s is y. But let's leave it as y and x. So the gradient of this the equation for this line is y equals 3x. The equation for this line, well, you don't know yet, but you would need to work out the area underneath the graph. Okay? Well, anyway, just take my word for it for the time being that the gradient of this line is 3 x squared. Sorry, the equation for this line here is y equals 3x squared over 2. It's just like that that famous equation. This gt squared over 2. When an object free falls from the tower, it will obey this, and the gravity is, well, there's always the acceleration, the gravity is always constant, it's always there. Well, anyway, the acceleration, well, this g here is really an acceleration, because when you drop something off a tower, when you drop a cannonball off a tower, the gravity, no matter where the ball is, the gravity is always pulling it down by 10 meters per second squared. So even if the ball's here, the gravity is still pulling it down 10 meters per second squared. In your case, the car number 2, there's an acceleration in this direction of 3 meters per second squared, meaning that no matter where the car is, there's always an acceleration in this direction of 3 meters per second squared. Even if the car's here, there's always an acceleration of 3 meters per second squared. Even, it's like a cannonball. Even when the cannonball's over here, there's always an acceleration of 10 meters per second squared downwards. Okay, so basically your 3 graphs will look like this. Okay, the question is, let's look at the distance covered. Well, in this case, the distance time graph is really useless. It's better to use the speed time graph. Try and work out the distance. So hang on. Let's clear this up. So car 1, car 2, car 2. The distance time graph is, sorry, the speed time graph is always very useful. Speed time, speed, speed time. So here you've got a situation where the car is going at constant speed of 10 meters per second, whereas this one here, well, let's superimpose this. It will look something like this. So this is car 2, car 2. Okay, let's forget about this. Now, well, if you want to if you want to find out which car crosses the 100 meters mark first, well, the distance traveled for car 1 would be the area underneath this curve here. Oh, sorry, the straight line here. So the area underneath this, well, you want to know what time it is when the area is 100. Okay, and if you look at the car 2, hang on, the speed time graph for car 2, you want to find out what time is it when the whole area here is 100. Okay, so that's what it boils down to. For you to answer this question, you need to look at the speed time graph. So hang on. Let me do it again. So speed time graph for car, this is car 2, and for car 1 here. You want to find out when let's just look at car 1 for the time being. You want to know when the area here equals 100. So what time will it be when this area here equals 100? So, well, this here is 10, because the speed time graph for car 1 is always 10. Okay, so basically get this height, times it by t. Well, we don't know what t is yet. So the area underneath here would be 10 times t. Okay, so it will be 10t. That will give you the area of the whole thing. But we want to know when t will give us an area of 100. So we put it into an equation like this. Okay, so now find out t. Divide both sides by 10. So t equals 10. Okay, so this car will finish the race when t equals 10. Okay, and then now look at car 2. Hang on, car 2. The speed time graph for car 2, speed time graph for car 2 would look like this. And remember, always start with this acceleration time. For car 2, it will be 3 here. So the speed time graph will be y equals 3x plus c, but c is 0, so we forget about c. So the equation for the speed time graph is this thing here. So that's important for us. So y equals 3x. Well, in this case, x is the same as t, but let's leave it as y and x. So we want to find out the time when this area will be 100. Okay, because we know that the area underneath the speed time graph represents a distance traveled. So we want to know what time it is when the distance traveled is 100. Okay. So that's why, yeah. So we want to find out the time when it will give us an area of 100. Now let's look at this. What is the speed when? Well, what is this height here? Well, this height here is this height here will be we'll put t into this thing here. That will give us a height, because here we've got an equation for the straight line. So put t into this thing here. Okay, so the height here will be well, if you put t into this 3 into the x here, it will the speed here will be 3t. Okay, and then the distance here across here is t, because we want to find out we want to find out the value of t here when the two when it would give us an area of 100. So we would get the height times this t here. So the height 3t times a t. Okay, so you get 3t, and then you times the t, and then because it's a triangle, then we divide it by 2, and that has to be 100. So basically, we remember t could be somewhere down here, or it could be somewhere inside here. Well, let's just call it t for the time being. When is it that what is this value here when if it were to give us an area of 100? So you would put it into an equation like this and make it equal to 100. Now tidy this up. It will be 3t squared over 2 equals 100. Okay, because the t here times with the t. Now you're just trying to work out the time here. Okay, so time here will be well, try and work out t here. So this would be 200, because times both sides by 2, and then divide both sides by 3. So 200 over 3, and then square root both sides. So t equals root 200 over 3. Okay, so jump to a calculator. Hang on, calculator. Let's hang on. Where's my square root? Square root. Where's my bracket? Okay, let's do it like this. 200 divide 200. Not hang on. 200 divided by 3 equals this 66.6666. Well, anyway, square root that. Hang on. Square root 60. Hang on. Let me do it again. Sorry. Square root 6. No. Hang on. 66.666666 here. Square root here. It will give us that. So t here. T equals 8.16. So t equals 8.16. So what that means is that car 1 will cover the distance of 100 meters in 10 seconds. Car 2 will cover the distance of 100 meters in what was it? In 8.16 seconds. So really, car 2 wins. Okay. Now let me show you this graph here. Hang on, let me clear this. So this is a graph of distance, and then this is time here. Okay. So remember, with car 1 here, inside your mind, you would start with the acceleration for for car 1, the acceleration is 0. Then the speed time graph for car 1 would be like this. Sorry, the speed time graph for car 1 would be like this. It would be a horizontal line, and then for the distance time graph for car 1 would be a diagonal line like this. So this equation here is y equals 10, and this equation here is y equals 10x, because when you have a straight line like this, the gradient represents the speed, and the gradient here is 10. So what I did was for the blue line I plotted y equals 10x. Okay, that would give us the distance time graph for the blue line. Now for car 2, inside your mind you should have visualized this. The acceleration time graph, it would be 3. Okay, 3 here. So this line would be y equals 3, and then jump to the speed time graph, and it will look like this. Okay, and then it will be y equals 3x. Now, when you and then the distance time graph, it will look like this. But the thing is, at every point here, I would get the height here. Well, this thing here boils down to is similar to this, h equals gt squared over 2, which means that when you have the speed time graph like this, it would give you a graph of y equals well, g in this, well, it would be 3x squared over 2, and I've explained this before in one of the earlier videos. In the next video I'll probably clarify it once more, but so when you have the speed time graph for this, the distance time graph will look like this. Okay, in the next video I will clarify this. And so for me to plot the red line here, I did y equals 3. Remember, 3 is the acceleration. 3x squared over 2 here. Okay, so it will look like this. Now look at this. Because this is a distance time graph, this is the 100 mark here. This is our distance. You see, car 1. Remember, as we move across, so this is time. This is time as we move across. So here, this is a 100 mark here. You see, the car 1 will hit the 100 mark, and then car 2 will hit the 100 mark. Can you see that? So this is, well, car 2 did it in about 8 minutes. Sorry, 8 seconds something. Whereas car 2 did it in 10. Okay.